So I'm here to discuss transformers, and that too basic of transformers. We will discuss very basic things, okay? And if you have some practical or related queries, then you can definitely ask. All right. So transformer is a device, electromagnetic device. Electro means related to electricity, magnetic means related to magnetism. So these two things interplay and we form a transformer. The name itself is meaningful. It transforms power from one level of voltage and current to another level of voltage and current. Power from one end to the other end remains constant. Okay? Ideally, every word is important. It transforms power from one level of voltage and current to another level of voltage and current. It is an electromagnetic device. That means its operation is based on electricity, that means the flow of current and the associated magnetic field. All right. And we use transformer in transporting the electric energy, electric power from one end to another end. And in our power system, the very basic, very fundamental of the power system is that we have to generate at one end and transport it to the other end where the load is located, where the consumers are located. And in between, we have very, very complex power system that comprises of generators located at different parts of the country. Then those generators are connected through a network of transmission lines. And these transmission lines are joined together by transformers. Generator at the generating station is joined to the network of transmission lines with the help of transformer. And when we have reached to a point, a transformer is again used to connect the load industries to the transmission infrastructure or transmission lines. So that way, power system is having three major components: generation, transmission, and distribution, and then finally the load, where and the loads are connected to the distribution point. Okay. And in between, wherever there is a need for voltage upgrade, voltage up requirement, that means stepping up of the voltage or stepping down of the voltage, we use transformer. All right. We will see various other uses also. Transformer is a AC device, alternating current based device. That is why it is used in power system which transports alternating current. It is commonly used to increase or decrease the supply voltage without a change in the frequency. This is also important. It does not changes the frequency. Why? We will see, but as a prior information, transformer, you must be knowing, has multiple windings. Basically two windings. One to which the supply is connected, and the other one where the load is connected, okay? Or the primary where the supply is being input, and the other one is called secondary where we are taking the power, okay? And these two windings, they link to each other because secondary gets power whatever primary supplies, all right? And where is the linkage? Linkage is in between where there is a core, there is a flux which is magnetic, okay? There is no electrical connection between the two windings of a two-winding transformer. They are electrically isolated. They do not touch each other. No winding point touch each other. That is why they are electrically isolated, but they are mutually coupled through magnetic flux, okay? The transformer works on the basic principle of electromagnetic induction and mutual induction, okay? The linkage of a common flux to both the winding, which induces electromagnetic force, and whenever there is a closed circuit involving that particular winding, there is a flow of current and flow of power. In a step-up transformer, output voltage is increased, and in a step-down transformer, output voltage is decreased. This is a basic definition. A step-up transformer will decrease the output current, and the step-down transformer will increase the output current for keeping input and output power of the system equal.
The winding जैसे साइज जैसे कैपेसिटी बड़ी होती है तो वाइंडिंग भी उस हिसाब से फिर बड़ी होती है। तो ऐसा कोई डिजाइन नहीं होता कि जिससे कि हम वाइंडिंग कम करके ट्रांसफार्मर का डिजाइन थोड़ा शॉर्ट कर लें, डिजाइन थोड़ा कॉम्पैक्ट कर लें, ऐसा कुछ टेक्निक?
वाइंडिंग कम करके
वाइंडिंग साइज बड़ा होगा तो फिर उस वाइंडिंग भी बड़ी होगी, ओके? मगर ये कि अगर आप कॉम्पैक्ट साइज का बनाना है।
कॉम्पैक्ट का मतलब आपसे क्या है?
जैसे 3 फेज का ट्रांसफार्मर बनाना है हमें, 1000 केवीए या एमवीए ले लो, ठीक है? तो उसको अगर आप कॉम्पैक्ट बनाना चाहते हैं, वो तो काफी बड़ा होगा साइज, ठीक है? बड़ा बनाना चाहते हैं तो उसके लिए हम वाइंडिंग में कुछ ऐसा नहीं कर सकते कि जिससे कि हम एक वाइंडिंग से कुछ ज्यादा वोल्टेज जनरेट कर पाए।
अच्छा, देखो इनका भाई एक सवाल है जो क्लासरूम में बैठे हुए हैं, क्या नाम है? अमन ग्रोवर जी। ये ट्रांसफार्मर के साइज से बड़े परेशान नजर आ रहे हैं, कह रहे हैं भाई हमें कॉम्पैक्ट बनाना है इसको। वेरी गुड कंसर्न।
सर वो जो हेलो सर, मैं एक बात कहना चाहता हूँ।
जी बोलिए।
वो जो ट्रांसफार्मर का ईएमएफ इक्वेशन है 4.44 इंटू 5m इंटू n, तो उसमें 5 के जगह में b इंटू a करके अगर पुट करें तो वहां से डिजाइन का कैलकुलेट जो एरिया को बढ़ाना कमाने का जो प्रोसीड्योर है जो बताया, तो उसमें से कैलकुलेशन करके निकल सकते हैं जो बड़ा होगा क्या कम होगा।
हाँ। वो तो कैलकुलेशन की बात है, वैसी तो कैलकुलेशन से मैथमेटिक्स से सबको समझ में आती है, लेकिन इंजीनियर्स को जो है ना वो देख के और फील करके भी समझना चाहिए, है ना? मैथमेटिकल कैलकुलेशन तो फीलिंग नहीं देते हैं। तो मैं जो आपको बता रहा हूँ इनके दिमाग में जो फिक्र या कंसर्न चल रहा है उसके हिसाब से बताता हूँ। भाई इनका है कि हम साइज को कम कर देंगे, तो साइज कम कैसे होगा? जो वाइंडिंग है वो पतली होना चाहिए, तभी तो साइज कम होगा। उसकी कोर जो है वो पतली होना चाहिए, उसका इंसुलेशन जो है वो पतला होना चाहिए, है ना? तो साइज बढ़ता है दो चीजों से, एक करंट से और एक वोल्टेज से। जब आपका जो ट्रांसफार्मर है, ट्रांसफार्मर का केवीए और एमवीए ज्यादा होगा, दैट मीन्स वोल्टेज एंड करंट रेटिंग्स आर मोर। Voltage affects the insulation and current affects the wire diameter या वायर का साइज, कॉपर का साइज। अब इन दो चीजों को अगर आप कम कर पाते हैं, then you will definitely reduce the size of the transformer. अब now to reduce these two size, you have to have very special material in terms of the insulator, which you can use even a thin layer, and it can protect kVs of voltage. Okay, which is
उसमें एक हेलो
हाँ बोलिए.
उसमें ये एक हो सकता है वो जो V/F का जो रेशियो है
Air is
ठीक
not
है
a very good insulator. Definitely it is, but it has a rupturing capacity. Okay, so
सर
there are even better insulators than air. They are being used in transformer and machines. Okay, there are various types of coating, varnish type of coatings which are being used, paper which are being used, wood that is being used. Okay, and other insulating materials which are being used in machines and transformers. Okay, even then you
सर
need some. Yes.
सर सर वो जो आप बोल रहे हैं ठीक है तो वहां पर जो V/F का जो रेशियो है ठीक है वो तो कांस्टेंट रहना चाहिए ना
V by.
V/F का जो रेशियो है वोल्टेज बाय फ्रीक्वेंसी का उसका जो रेशियो है वो तो कांस्टेंट रहना चाहिए ना तभी तो फ्लक्स कांस्टेंट रहेगा नहीं तो फ्लक्स तो अगर V/F का रेशियो अगर कांस्टेंट नहीं होगा तो फ्लक्स का जो वैल्यू है वो भी तो नहीं कांस्टेंट रहेगा ना.
चलिए वो उसकी बात हम बाद में करेंगे. उसकी बात
सर
हम बाद में
उसमें
करेंगे.
उससे तो रिलेशन है सर ये डिजाइन का.
हाँ है, डेफिनेटली है, डेफिनेटली हम फ्रीक्वेंसी की बात इसमें नहीं, यहाँ पे नहीं कर रहे हैं.
वो साइज के बारे में बोल रहे हैं तो वो तो V/F का रेशियो से भी निकल सकते हैं ना.
अरे भाई मैंने साइज की बात की. साइज जो आपको अफेक्ट करेगा वो आपके इंसुलेटिंग मटेरियल और वाइंडिंग के साइज से अफेक्ट करेगा. अगर अब आपका मटेरियल वाइंडिंग के मटेरियल पे हम बात करते हैं, जनरली वी यूज कॉपर. इफ यू कैन invent any other material type which can carry larger amount of current with a thinner diameter, then you can accommodate that, but that is a gradual uh, innovation which is required. Okay, at present we are doing with what is available. All right, so you can work on these two areas where you can think of reducing the size of the transformer given the capacity. Okay, chaliye. All right, this is how we understand the operation of the transformer. We have a primary winding, we have a secondary winding in a two winding transformer. A transformer can be of multiple winding. Okay, but basic two winding transformer has this construction. So windings, primary, secondary, number of turns may be varied depending on the application requirement. They may be same. All right, primary is having a certain number of turns. If the secondary is having higher number of turns, then it is a step up. If it is lower number of turns, it is a step down. Okay, and in between there is a core, ferromagnetic material core, which is laminated. Laminated means a thin stems or thin stems are used to form the core. Okay, there is a reason of using thin laminated cores that we will discuss later on. And when you apply a supply to one of the windings, say primary, a current flows. Okay, when current flows, and you can use Fleming's rule, left hand right hand rule, okay, to determine the direction of the flux which will be set up in around the winding. Okay, around the winding. So sorry, not Fleming's this left and right rule that is used for a motor and generator, Lenge's law. Okay, like you hold this in the current direction, and the folding fingers will tell you the direction of the flux. Okay. Similarly, when you can see in this corner, this flux setting up is shown. Okay. And some of the flux which is coming out or coming in a closed loop, what the core does, core tries to accommodate all the flux lines within itself. It tries to minimize the leakage of the flux in the air. Okay, so air has lesser permeability than the ferromagnetic material. It supports, as if the conductor supports the flow of current, ferromagnetic material supports the flow of flux. And then flux, like a current, flows in the core and it links to the secondary winding. All right. And because the input which is applied to the primary is alternating current, flux is also alternating. If the current is sinusoidal, flux will also be sinusoidal. Okay. And when the changing flux links with a coil, you know that EMF is induced. Okay. According to Faraday's law of electromagnetic induction. And that way we get the induced EMF, and if we close the circuit, and a current can flow. Okay, and we can extract the power which was input at the primary. Okay. This is how you can see the other way, the forming of the lines of flux. All right, so do I need to go into the detail of flux formation? No. Okay. So let us cover these points. Transfer of electrical energy from circuit to another. Okay. Transfer of electrical power through electromagnetic induction, that is, we have discussed. Electric power transfer without any change in frequency, that we have discussed. Two circuits are linked with mutual induction. Okay, that we discussed. All right, this is also we have covered. Interesting part is that reverse is also true. That means current helps in the setting up the flux, and flux helps in setting up of the current. So vice versa. When a magnetic flux lines fluctuates around a piece of wire, a current will be induced in it. This was what Michael Faraday found in 1831, which is the fundamental working principle of electric generator as well as transformer.